just in case. I'm going to keep everything down. Okay. Okay, Pascal principle. Now Pascal principle 呢，就是讲到 fluid，alright， 讲到 fluid 的。Now 什么是 fluid？ 我们先讲what is the definition? What is really fluid? What does fluid means? Right? So when you think about fluid, right, straight away you think about water. Okay, water, gases. Actually, gases is also considered fluid. Right? Now let's look at the properties of fluid for a moment. Okay. Now, fluid, we can define it as like anything that takes the shape of a container. All right, anything that takes the shape of a container. For example, 如果我有一个 let's say I have a rubber container, a spherical 圆形的 rubber container, let's say lah, right? So here, and also if I have like a dumbbell shaped container, whatever irregular shape lah, okay? So the fluid takes the shape of the container, right? So not necessarily water, it can be water, and also it can be gas, right? So there are two types, just water and gas. Solid is not. So solid has a fixed shape, right? Only water and gas follows the shape. Now, what are the difference? Since these two, they are considered fluid, 可是它们有什么分别呢？ Okay, 我们先看 the main difference between these two is that water, or we call it liquid, okay, any form of liquid, one is compressible and the other one is not compressible. Okay, gases A, right? So gases is, we said it is compressible. Compressible. Okay. Now, compressible means what? As the word suggests, it can be compressed. Okay. Now, for example, let's say 我给你一个 example. 如果你拿一个let's say 我拿一个 balloon, 然后我装满 air inside. Okay. Can I compress the balloon? I can compress the balloon, right? 我可以按它 decrease 它的 volume. Now, what happens when I compress the balloon is that I am reducing the volume, right? I am reducing the volume. So what happens to the density? We all learn about density, right? Density equals to mass per volume. 对吗？是不是？ So 如果你的 mass 是 constant 因为你的 amount of particle 在那个 balloon 里面是 constant 的嘛，会变的嘛。So if I decrease the volume, what happens to my density? My density increase, right? Right? Inversely proportional, right? So if I decrease the volume, my density increase, meaning that by compressing the balloon, right, 我可以换 I can change the density of the air. I can change the amount of density in that fixed volume, right? So this is an example of compressible, right? So if let you just imagine 啦，如果你装满 air 是 somehow 你还可以按它的嘛 ，right？ 你按它是你 change 它的 density and at the same time 你再增加它的里面的 pressure, right? You increase the pressure inside because the volume getting smaller, and the amount of particle is still the same. Now what happens at some point, it cannot withstand the pressure anymore and it pops, right? So we say that gases, they are compressible. Okay, so in other words, compressible means that we can change the volume and the density. Okay, remember, I repeat, compressible means that we can change the density by changing the volume. Now, 现在我们讲 water in contrast to gases, water 是 incompressible. Okay, notice the word, the keyword is incompressible. Okay, now incompressible means you cannot compress it lah. So for example, let's take the same balloon. Now this time the balloon 我们装满water. Now the water has to be like extremely like no spaces anymore, like fully fitted with water 装满. Alright, so if you 如果你装满这个balloon with water, right? So you cannot compress it anymore. You realize that, right? No matter how much force you apply to compress this balloon, you cannot decrease the volume. simply because the water is incompressible. All right, so this is first you have to know that the difference between these two. Okay, so I repeat, no matter how much force you put on the balloon, you are not able to change the balloon because liquid generally they cannot be compressed, right? So same thing, not only balloon, if you change it like a container, a rubber container, okay, you fill that up with liquid, packed with liquid, you still cannot compress it, right? It will repel there's a repulsive force is as strong as the force that you apply, right? So these are the main difference between liquid and gas. Now, let's go in a little deeper. Okay, let's go in a little deeper. Now you know that the difference between incompressible and compressible. Okay, let's take, for example, let's take a weird container, right? Let's take a weird container. For example, I draw it out, a YouTube container here. Okay, now this YouTube container, you have, here is the opening, and then at the right side also the opening. Now the right side, the opening is larger, the surface area is larger, okay? So now if I put a piston at both opening, the left opening, I put a piston, okay, I use different color here. Okay, so this is the, okay, so this is the piston. Okay, sorry about my drawing, I'm trying my best, right? Okay, so here also another piston. Now, here is let's say we have this area 2. Area 2 is this one here, the opening here, or the area of the piston, okay? And area 1 is this one here, over here. Now, let's say 如果我这个 YouTube will fill in with water here. So here is water or liquid, any liquid. It can be water, or oil or water. Now completely fill, remember, completely filled in with water. Now, what happens at these 2 points here? Okay, let's say I take this point as X and this point as Y. Okay, now what happened when I compress the left piston? Okay, imagine 我按左边的 piston, I applied force to compress it down. Okay, now as I apply the force, I am applying a pressure at point X. Okay, pressure at point X, so I write Px. I'm pressing down the liquid, right? I'm compressing the liquid from this end, so I'm applying a pressure. So can we calculate the pressure at point X? Yes, we learned about pressure formula, right? So P at X equals to F1, the force as the small piston, divided by the area of the small piston, right? So this is pressure at X. Now, just now we talked about the liquid is incompressible, right? So we cannot change the volume, we cannot change the density. So because liquid is incompressible, so it gives us a very good benefit on this Pascal principle, is that when we compress the force, right, when we apply force on this end, all the pressure will be transmitted efficiently. What do I mean by efficiently? 意思说 pressure 它可以 transfer 从 point X all the way to point Y without losing any pressure, So there's no loss of pressure, right? Meaning that, in other words, pressure at point X is the same as pressure at point Y. This one you have to remember, this one. Okay, basically this is what all Pascal principle is about. All right, so all this green arrow is the pressure, okay? So you know that the pressure of liquid X at all direction, right? Pressure of liquid X at all direction. So it acts at the wall of the container, and it is also transmitted all the way to the second piston, this one, piston Y. Right? So piston Y, the pressure is the same as X, at X. Right? Now what happened here is that when you have the same pressure, but you have a larger area. See, you see piston 2 is like larger, right? Piston 2 is larger area. So what happens if we look at the formula, right? P equals to FA, P equals to F over A. 如果我们的 pressure 是 constant, what happens if our area increases? Our area increases, so 我先搬这个过去了 okay, so F equals to P times area, right? So if we have a constant pressure, but our area increases, meaning that our force will increase, right? Our force will become bigger if you increase the area. So what happened at the right side of the piston is that as you press down the left piston, pressure is being transmitted. Since the right piston having a bigger surface area, then it will exert a greater amount of force. All right, so this is F2 here, F2. So F2 is bigger than F1. Okay, so F2 is bigger than F1. So this system is something like the lever. It's like you apply a small force, but you get a big force. Okay, like lever. Okay, so lever. What is lever? Lever is the simple machine, right? Like you have a plank here, and then you have the fulcrum. This is the fulcrum, the fixed point. Okay, this is the load. This is the load, and then you apply the effort, right, to lift it up, right? So you're applying a small amount of force. Because of the lever slipper system, it allows us to do work easily, so we can lift up the load easily. So this one is the same principle as that one, right? We apply a small force on the first piston, and then it can lift up a bigger object at the second piston, right? Now, Pascal principle 呢，记得，如果 for this to work, right, for this whole thing to work, you have to make sure that this one, the region between the piston 1 and piston 2, okay, cannot have bubbles, cannot have air bubbles. Okay, so I write this down here. This is like, it has to be, first, it has to be completely filled with liquid, okay, and it must be liquid, cannot gas. Why it cannot be gas? 因为刚才我们已经讲了嘛，是不是？因为如果是 gas 的话呢，你可以 compress 它。如果你可以 compress 它，是意思说，当你 apply 那个 force 在第一个 piston 时，那个 pressure 不会 transmitted to the second piston efficiently， 它会有 loss of pressure, right? So there is a loss of pressure, meaning that you will not get the same pressure at the other end, right? So it must be liquid. It must be liquid. So we need an incompressible liquid, right? So this is the first condition, the first criteria. Now, second criteria is 我们不可以有 air bubbles, no air bubbles. 为什么？因为 air bubbles 是 air 嘛 compressible, all right? So cannot have air bubbles, right? Now, if you look at the definition of the Pascal principle, okay, 我写下来 somewhere here lah. Okay, I just write down for you to see it. Actually, it's in your textbook, but I'll just write down. Pascal principle states that pressure okay, so this is basically what the Pascal principle says. So if you look at the sentence here, yeah, you have to memorize this lah. If exam they ask you this one, right? Pascal principle states that the pressure applied to an enclosed fluid is transmitted uniformly. Now, this keyword transmitted uniformly meaning that with no loss, okay, constant, okay. So pressure at F equals to pressure at Y to every part of the fluid, okay. So pressure is acting in every direction, every part of the fluid, and to the walls of the container of the liquid. Okay, so this entire system, we call it what? We call it what? The hydraulic system. Okay, you have heard about the hydraulic system, right? Hydraulic system is what? Your power steering. Okay, the power steering in your car. Okay, you apply small force, you are able to turn the wheels. Without power steering, what happens? It's very difficult, right? It's very difficult. Why? Simply because you need greater force to turn the wheels. With the hydraulic system on, you only, same like the hydraulic system, right? Inside the system, they also have two pistons, also this one, right? You apply the force, you turn the steering, you apply the force on the first piston, and then it exerts a greater force at the second piston. Okay, now, so formula from here, let me just erase 这个上面右边这个。Now, 一下啊。Okay, so since pressure at P, okay, I write, what's it? Px equals to Py. So I can write Fa, F1A1, sorry, Fxax, 就是 force and area at x 啦, right? Equals to Fy over Ay. So we can calculate the force exerted on the other piston and bring it this one over there. So we get like Fy equals to Fx over Ax times Ay. Right? This one. So that's how we calculate. The Fy is always bigger than Fx, the magnified force. Okay. Now let's go to the next part. 如果你要 screenshot 这个，你可以 snap 下来。Okay, let's take another example here. So I write down a few key points for you. Okay, so we have the same hydraulic system. So always from the smaller piston to the bigger piston. Let's say here. Okay, so it is same hydraulic system that used to raise up the car in any of the mechanic shop, right? They use the hydraulic system raised up. So this is the smaller piston again, and this is the larger piston. So this is the hydraulic oil or any type of fluid, right? So at point X here, same pressure at point Y. So you have to remember, 当你遇到水的时候是，就是 anytime you deal with water 啦。Okay, water, right? The pressure is the same at every level, at the same level. Okay, doesn't matter if my container is like, if this is my conical flask, for example, I write down like this. This is the conical flask, and it is connected to a test tube, let's say. Okay, both you fill with water here, water here. So at same level, the pressure is the same. Here and here is the same, XY. Okay, and here also is the same, PQ. Okay, so for water, as long as they are at the same level, then the pressure is the same. Okay, so provided the tube must be connected lah. Provided the tube must be connected. Okay, so here pressure at point X are the same. So here I write down a few key points for you. So you said that Pascal principle can be used as a force multiplier, okay, in a hydraulic system. Okay, it can be used as a force multiplier. And also smaller force overcome bigger load. Okay, this is number one and number two. Number three is that what happens if there is an air bubble? How do you explain it? Okay, for example, the question asks you, if there's an air bubble in a system, how does it affect the system? Okay, so you write this down. If there is an air bubble Okay. Okay, so if there's air bubble, the pressure applied to the piston in a master cylinder is the first cylinder, the smaller cylinder, the cylinder where you apply the effort, okay, will not be effectively transferred to the slave cylinders. So for example, this one, the bigger one is the slave cylinders. This is the master cylinders, okay, as the air bubble is compressible. Now, next one, we will look at a few applications of the hydraulic systems, okay. Now, the first example, the most typical one is the hydraulic jack that you use to jack up your car, okay. So whenever you have a a flat tire, you use the hydraulic jack, right? So I'll explain how does the hydraulic jack work, okay. Now, before that, let me do a simple sketch of how does it. Okay, you guys take a snapshot of this one first. Just want to Okay, this one, it shows the internal structure of the hydraulic jack. So here you have a piston. Here also you have a piston. Okay, so this is the large piston. And here is the smaller piston, right? Small piston attached right under the handle, right? So this shows your car tire and the bottom part of your car. So the hydraulic fluid is here. Let's put it in green. This one. This is where the hydraulic fluid lies. All until here. And then here you have like a release, like a valve. They call it the release valve. Okay. So the smaller cylinder, where is the smaller cylinder? Okay. So you know that Pascal principle, you have a smaller cylinder and larger cylinder, right? So small cylinder is this one here, just underneath. Now, what happens? How does it work? How does the hydraulic system, how the hydraulic jack work? Now, look at this one. This is the reservoir storing the hydraulic oil. Okay, and actually you have two valves here. This red color, we call it valve A, valve B. Valve is like an opening lah. Okay, you can close it, you can open it. Okay, valve A and valve B. Now, what happens when the handle is raised? Before 我按下去是 when it is raised, valve B is open. Okay, so when it is raised up, valve B is open. So what happens when valve B is open? So valve B opens and valve A closes, right? So the hydraulic oil will flow from the reservoir inside this small cylinder. Okay, look at my pink arrow. Okay, purple, pink, it doesn't matter. Now, hydraulic oil will flow from here and enters the small piston section. Okay, now as you press down the small piston, what happens? You press it down and valve B will close. Valve B closes and valve A opens. Okay, and at the same time, as you press it down, you are pressing this small piston downward. Okay, so this small piston, what happens? It will push the hydraulic oil and enters valve B all the way to the larger cylinder, right? So that's how you pump the hydraulic oil inside the overall the space here, right? Now, so if you only focus on these two sections, this one and the larger cylinder, okay, it works like just now what I've shown you, right? So if you keep pressing it down, then you are slowly applying the force to raise up the car. So this is how it works, right? So what is the function of the release valve here? Release valve is like if you press this button, like if you pull this out, right? You pull this valve out, you're opening the valve. Then all the oil from the larger piston here, it flows back to the reservoir. Okay, flows back. Okay, so it's like one button. Okay, so this is a simple application of the hydraulic system. So without the Pascal principle, without somebody inventing the Pascal principle, it's like it's very hard because hydraulic is you see it everywhere. Okay, for your car braking system, same hydraulic system, right? You press the brake pedal, what happened? There's a piston there. Okay, there's a piston underneath your brake pedal, right? The small piston. So you press it, and then it transfers the brake oil. You have the brake oil, right? So brake oil, you have to make sure that always you have to refill the brake oil. Why? Because it acts like a hydraulic oil. You need the brake oil for you to like the whole piston system, right? Same, you see it in the airplane also. Okay, if let me draw the airplane. Wait, draw the airplane here. For example, you have this. Okay, if you look at the structure of an airplane, 你看它的翅膀的后面这边this is the engine, right? This is the engine, and the other side also the engine. If you look at this front part, actually we call it leading edge. Okay, it's like the leading edge at the front. Okay, this is the trailing edge at the back. Okay, at the trailing edge, you see like there's we call it the flap. Okay, the flap of the wings. You can adjust up down movement. Okay, or you call it the aileron. Okay, aileron here. So the function of the aileron is simply help the aircraft to give it the rolling motion. Okay, what is the rolling motion? It's like this motion here. This one, the green arrow is like rolling. Okay, if you look at the three axis, right? I draw the three axis, right? This is the z axis, and this is the x axis. This is y axis. Rolling motion is like around the x axis, right? This is the roll. Okay, so that is the function of the aileron. So it uses hydraulic as well. Okay, it uses hydraulic. Without the hydraulic, you cannot control the aileron. It's very difficult. It's very like the human. You need a few human hands to push it. Okay, it's very hard. Okay, without the hydraulic system. Now, same at the back. At the back, this one, you also have the same thing here, like a flap. You can move it at the small tail here. This one we call the elevator. Okay, elevator 用来做什么的呢？就是 control 你的 up down motion。我们叫 pitching。Okay, so like this or like that. You pitch your nose up or you pitch your nose down. That is called the pitching motion. Okay, so pitching motion is like around the y-axis. This one, around the y-axis, the rotation around the y-axis, right? You can somehow imagine that elevator. And what else we have? Another one, the last one is the rudder. This one at the back. This is at the vertical tail. You have the horizontal tail and the vertical tail. This is a vertical tail here. We call it the rudder. Okay, so rudder is simply to control the yawing motion. Okay, yaw is like around the x-axis. Sorry, around the z-axis. This is the yaw. Okay, this is roll, yaw. This is what? Pitch. Right? So yaw is like this. Let me draw it. 这样子，然后这样子，左右这样子啦。Okay, so this tree, right, we call it the control surface. Okay, control surface of an airplane. It basically it controls all the movement of the airplane in all directions. Okay, so this tree, why I want to show you this tree is somehow lah, not really related lah, somehow related to hydraulic, because all of these tree, they uses the hydraulic system, right? So 如果你有看那个，我不知道你们有没有看那个，我很喜欢看那个 air crash investigations. Okay, back in the time when everybody is at home watching the Astro, right? There's this very nice channel, air crash investigation. So you see that some pilot, right? Sometimes 他们要拉那个飞机上来是很像要出很大力这样子 because the hydraulic leakage, there is a hydraulic leakage. So they have to exert much greater force just to control one single control surface like the aileron, right? So without the hydraulic, technically they cannot control it. Okay, like they are flying without any control surfaces. That is very, very dangerous. It can lead to disaster. Okay, now, OK， 我看到上面只剩下1分钟，然后我再send那个 link 给你们，你们再进来，然后我们再继续。Right